feels like it's related to the powers. I think there's a connection with the power series there, but we don't need to talk about series. Oh wait, for once the YouTube chat just like worked instantly, or the YouTube stream. Okay. The nth derivative x. Really? Okay, fine. We have 1 plus x to the n, and we want the nth derivative of it. So let's start by getting the first derivative. That's not how you write that. So n is just a constant. We can do the power rule with the n, so the n will come out front. The inside stays the same. Now the exponent gets reduced by 1. And then you don't get anything from the chain rule, you just get 1, so that doesn't really matter. Now let's get the second derivative. So I'm writing it in a little bit of a weird way, but I have a reason for doing this. We're just going to take the derivative of this thing again. So the n stays out front, it's a constant coefficient. Apply the power rule again, the n minus 1 comes down. 1 plus x, now the exponent gets reduced again. Oh. Symmetry got first, nice. You're gonna have to learn Maclaurin series. Ooh, okay. I think they're fun, but they're definitely a little bit of a stumbling block for a lot of students. So just to show the pattern with 3 things, take the derivative of this again. These are still constant coefficients in front, so just do the power rule again, n minus 2. And then we get n minus 2 for the exponent. So if we continue this pattern n many times, what we're going to get is n times n minus 1 times n minus 2 all the way down to 1. We shouldn't be the only thing, yeah, all the way down to 1. And then what happens to the exponent up here is we get 1 plus x to the n minus n. Just continuing along this pattern here, like there's a 2 there, there's a 2 there, a 3 there, a 3 there, n here, n here. So n minus n is 0. So this thing just becomes 1 because it's to the power of 0. So all you have is n minus 1, n minus 2, all the way down to 1, and that just happens to be n factorial. 3 minutes in, yeah. People were sleeping. Why do bad things happen to good functions? I don't know, BizBuzz. Why is it going towards 1? That's a good question, and I think it'll be easier to see if I plug a number in for n. So if I just pretend that n equals 3 and do the same exercise, we have 1 plus x cubed. I did the same thing again. I don't know why I'm doing that. We get 3 times 1 plus x squared. Three times 2 times 1 plus x to the 1. And now we've hit 3. So this is the last derivative that we're going to take. 3 times 2 times 1 times 1 plus x to the 0. So it's just a matter of if we start with n many exponents, and then we do the power rule n many times, we're taking down every single one of those exponents until we get to 1. If we went like d by dx to the n plus 1, we would get 0. Let's say we do n plus 1, we get minus 1, but I don't know if that's true. Like I hesitated when we were writing that once I was working the pattern out in my head too, to make sure we would stop at 1 rather than like 0 or 2 or something. But I think it's a little bit easier to see with actual like numbers like that. The oil and well, you need to get you need an oiler in order to change the oil in your car. Yeah, but no worries, Thunder. Yeah, exactly. Oiler. That's what Euler did, right? Zach, yeah, you need Zach to get the oil change in your car. Euler, I hardly know her. Yeah, that's a good question, though, Thunder. Thanks for asking. So I have been interested in doing the what's called the final. Sounds good, Thunder. And hey, Joseph. Okay. So I've been interested in doing the midterm for Penn Center's complex variables class. So that might be a nice like downtime activity to do while we wait to see if someone else turns up with a question. I thought it was a little bit funny to see duration XX minutes for a total of 0 points with the possibility of partial marks. I wonder if Penn Center like has to put those things, but he didn't want to put actual values. They're thorough and well explained. I mean, I'm not gonna actually like do all that stuff. I just want to like find the answer. That's only like 5 questions in total. Penn Center doesn't even make his students do all of them. But I think I can just do all of them. I don't think they're gonna be that bad for me. How hard is electromagnetism crit class? If you do the electromagnetism that I've been doing, very hard. It's like uses a ton of multivariable calculus. I really enjoy it, and I think it's worth doing, but it's really difficult. It doesn't have to be this hard though. You can get E&M books that don't even use any calculus at all and focus more on the concepts. And there's probably a middle ground too, where there's a little bit of calculus, but not too much. Freshman physics majors at Harvard use? Oh my god. I guess it's Harvard, but yeah, critical. I'm not very good at physics, so I have a hard time like giving that general of an explanation. It's a little bit harder for me because I don't have the same intuition for electricity medicine that I do for a physical like situation. Like if there's a mechanics problem with a ball rolling down a hill, I know about what should happen just intuitively. But with E&M, if there's an infinitely long cylinder of charge, I don't intuitively know what's going to happen with it. Hey, Joel. So I think it's a little harder because like most people don't have that built-in intuition for E&M, but if it's something you're interested in studying, or if you're gonna have to take it, it's not that bad. Actually, are you gonna take an E&M class? Because I might be able to tell you about a few streamers. One of them is right here. The streamer's in the room with us. Hey, Moth Sogling. Like, I wanted to ask, like, what your schedule when you go live, because I be having questions. My schedule is I go live on YouTube on Tuesdays, Thursdays, and Saturdays, basically starting 15 minutes ago, whatever that is in your time zone. And I generally go for at least 2 hours, but I've been normally going for like 3 to 5 hours. Just on Saturdays though, the first 2 hours are the physics like studying, and I'm not doing math help during that time. But if you catch me like on Saturdays after the 2 hour mark. So I asked Penn Center that exact question. A, I think it's after the due date now. B, Penn Center said that his students probably aren't going to be watching my stream, so just don't worry about it. So it is done with his like permission and knowledge. I don't know how you get permission without knowledge, but you know. It's a little like, I guess the students are only expected to do one problem from each of these sections. One of them they have to do a little like presentation for. I think the first 3, they write up a nice solution that's well explained. And one of these 2, they have to do a presentation on. I think it's the structure of the midterm. It's written out up here. Should I be watching the biggest math? Oh yeah. What's the best resource for linear algebra by self-learning? Mothsogling asks. I don't have a good answer that I've used for myself. I've heard that 3 Blue 1 Brown has a good linear algebra website though. So that's one that I've heard recommended that comes to mind for me at least. Yeah, students should plan to record a video explanation of one of the questions from the second set. Strings book? Oh, okay. Think you volunteered to be on stream with pens for that? Oh, okay. So we're working on Z sub 3. We're going to conjugate it. Sorry, Z sub 3, because this is Penn Center. Root 3 over 2i. That's the unit circle. Are we cubing it? Fourthing it. Fourthing it. We're definitely demoivsing this. Demoiv. That's unit circle, so the radius is just 1. The angle on the unit circle, this is in quadrant 3. It's like the angle pi over 3, right? Because x is 1/2, y is root 3 over 2. So pi over 3, but in quadrant 3, is 4 pi over 3? Wait, I just said that we're raising that to the power of 4, and I wrote a 3 there again. Oh my god. I was looking at the subscript 3. Then we can just apply normal exponent rules. Yeah, I agree with the 4 pi over 3 because we're conjugating. I would have expected us to get something unit circle that we could turn back into Cartesian. Actually, well, that might be Cartesian. Or that might be unit circle. We need to simplify it. Or get it onto 0 to 2 pi. So this is 6 pi over 3, but I'm going to multiply 6 pi over 3 by 2 to get 12 pi. Wait. Minus 6 pi over 3, minus 6 pi over 3. That should get us back on the unit circle. Oh, hey, we just come right back around to 4 pi over 3? That's weird. If we have 1 and a third, can we go around the unit circle 4 times? Is that what's actually happening if we raise it? Yeah. Sorry, or no, we do 1 and a third 4 times, right? So like that is the one that we're given. Then I think we're taking this and doing it 4 more times from there? I might be doing one too many. So wait, we go all the way 1 past it, plus a third. All the way to it, plus a third. I'm doing the Christmas colors. So wait, that's 1, 2, 3. Oh wait, okay, so this is, I ended right back where I started, so I did need to include that first red, I think. Huh. Hey, Mailman Joe. I get that a lot. Okay, so I was just gonna sanity check that if we get the same angle back, and I'm a little confused on whether you do want to count that first red rotation, but I assume you do. Do you though? Yeah, okay, yes you do. You do. Yeah. So funny enough, you just give the same number right back out because, well, not that same number, this same number. You would get a different looking number if the radius of this thing was not 1, but it is 1, so 1 to the power of 4 is still 1. Okay. Found a really good integral the other day, got you for 2 hours. Ooh, on Twitter? Let's see. Bored of these hot summer days and enjoy this. Oh, what the hell? Have you seen this one, syntax? It's arc cotangent of something. What's up, critical? Do it with contour integrals. Oh, interesting. I never studied contour integrals. Greg Egan, oh, I don't know who he is, but he's sure there. Mathematica can't evaluate it. That means Mathematica sucks. That's crazy, dude. It's a famous one? Okay. The bounds are symmetric. I might be looking if it's even or odd. Oh, I mean, the square root, it can't physically... Wait, what? Oh, I think the square root is going to break. Well, I don't know. I assume it's not as simple as an odd integral and it comes out to be 0. Jaden says to use King's property. I'm going to assume this one is beyond my ability. Let's look at what Critical posted. Four pi arc cotangent square root of phi, the golden ratio? Oh my god. Of course the golden ratio. Really good hard sci-fi? Oh, interesting. Oh, the polynomial is in there. Oh, yeah. If you ignore the 2's and the signs, which is a lot, but, you know. Which sets in 1 to 8 are bases for R3? I think we just take the determinant, see if they're linearly independent. Wait. What? What is the second sentence? Of the sets that are not bases, determine which ones are linearly independent and which ones span R3. If it spans R3, it is a base for R3, is it not? Change your car oil. Be a contour of the complex world. I really do need to study complex variables. Like, it's a cool thing. I know this depends in his class, but it's like, this is like the last week of it right now, and I think he said he's probably not going to get, he's only be able to introduce integration. Because it's really hard to get all that content into such a short class. I'm a little confused by the second sentence here, but it might end up not mattering if this is a basis for R3. And I think the basis has 2 requirements. Well, the other requirement is met because we have 3 vectors, if that's the other requirement. I need to integrate everything known to man. Until then, I'm not dying. Well, you probably have a lot of cool papers that you can publish in your lifetime then. Is that not the same thing as linear independence? Hey, mangoes, hexcodal. We just see what it looks like. Is it like Wordle? Oh my god. No. Okay. I should answer Critical's question. I do want to try this though. That's hilarious. Okay. Critical, I think the strategy here is just put these into a matrix and take the determinant. I freaking love that puzzle. Oh, Zach. My wrath. Thank you so much, Zach. Hey, Stephen Armstrong. I can get to your problem after this one. I hope your stream was good. Work on this problem here from Critical. And then I want to look at a puzzle that Mango's posted because it looks really funny. But I don't think this determinant will be so bad. Hopefully not. One, 0, minus 2. 3, 2, minus 4. Minus 3, minus 5, 1. And actually, we're doing the bars because we're doing the determinant. Dropping bars. Okay, let's expand along this column because there's a 0 in there. Plus, minus, plus. The first matrix we get is 2, minus 5, minus 4, 1. That, like, bottom right corner. Minus 2 times this matrix up here. 3, 2, minus 3, 5. And basically, if this thing comes out to be 0, then we'd say it doesn't span. Okay, the determinant, that's 2 minus 20 is minus 18. Minus 2 times negative 15 plus 6. Negative 9? Oh, dang it. We have to worry about the second sentence. So we have minus 18 plus 18, which is 0. So because it's 0, these are not a basis for R3. Sounds good syntax. Does 1 plus 1 equals 10? In binary, it does. My money is no one else's. Support. In binary, 10 isn't even. I'm not sure where that's coming from, Brian, but whatever's happening, I hope it's nothing too bad. If you're saying next, you're heading out, then I'll see you around, but so if the determinant is 0, it means that these three vectors here are not linearly independent. They either form a line or a plane in R3. They don't span all of R3. If you didn't get 0, then you conclude they're independent and they do form a basis, to my knowledge. Oh, okay, that's fair. That's a fair distinction there, Dr. Cook. Yeah, if you had like, if these three did span R3 and you added a fourth vector on, they would span R3 but not be independent. That's fair. Okay, and Jed found the linear combination that proves they're dependent. Oh, you're talking about rows, which I guess that also works out, but ideally we'd use the columns. Oh, hey, Maxie. It's been a while. I hope you're good. Determinant computes the thingamabob bounded by the vectors, right? It's something like that. If the volume is 0, it means they all point in the same direction. Oh, okay. Yeah, the columns are a little bit annoying, so there can be some fraction thing to get the middle row to add to 0. Like, you have to use 2 and -5 to add to 0. So there's gonna be some fraction involved to actually find the combination, but critical, I would say that it's the answer is that it's not a basis because you only have we might want to know how many linearly, is there an easy way to figure out how many independent vectors you have? You probably have to do row reduction. It's annoying. In the business, we call those thingamabobs. Oh, true. Okay, that's a nice point, Maxi. Yeah. Thank you. Okay, so what Maxi is saying is that just looking only at the first two vectors here, we know for a fact these are independent from each other because this 0, you can never multiply this vector by anything to make this vector. And the 0 makes it, I think, even clearer to see where 0 times anything is still 0. So you can never multiply this first vector by anything to make this 2. So we definitely have 2 independent vectors, and I assume there's some way to make this third one as a linear combination of these 2. So the answer that I would say to this question that I actually write on the test is that these vectors are not a basis for R3 because, well, we didn't necessarily even have to figure that out. These vectors do not form a basis for R3 because we do not have 3 linearly independent vectors. And I think that's the important part of the answer, at least. So association of rank with linear independence. I think you're right, Harambe. I don't remember the exact thing. Oh no, you're good, Fembox. Does that make sense? Critical, but also high. The determinant confirmed for us we do not have, these 3 vectors are not independent. I think I was getting a little bit too, I maybe wouldn't worry about the 0 here. Determinants out for Harambe. So critical, it's true what we said before about the 0, but I think it's getting a little bit too like It's doing a little bit too much work. To make a basis for Rn, you need at least n independent vectors. I should have said linearly. So they're asking if this is a basis for R3, so we need three linearly independent vectors. We're given exactly three, so we need to make sure that all three of these are linearly independent in order for them to form a basis. This determinant thing proved that we don't know exactly how many are independent, but they're definitely not all three independent. It's either one or two. We don't care about exactly how many because all we need to know is whether they form a basis or not, and knowing that we don't have at least three linearly independent vectors is enough to know that. That's what I'd say, rather than trying to find the actual Maxi, I think you can still span R3 while being dependent. If you have a set of vectors that span R3 and you add a fourth, they're going to be dependent, but they still span R3, to my knowledge. That's the point that Dr. Cook was making before, and that matches with my memory of it. It's not a basis? Oh, that explains the second sentence. Okay, a basis has to be independent? Ugh. Basis is linearly independent. Okay. Well, this is why I try to avoid linear algebra questions, because I just don't know this. Elliptic vectors can span, but oh, I misread what you put, Cook. Okay, never mind. Well, crap. Okay, let me. Exactly. Not at least, but exactly. Jed, yes, that matches my understanding at least. No worries, critical. I want to try out this hex code thing that Mango's posted, because it seems like a really funny puzzle. Hey, Waffle. Okay, so I assume we have to guess the hex code here. So this is like purple, and purple is what? Red and blue? So if it goes red, green, blue, let's just say there's like, let's go like, I don't know, BB red, 0, 0. Oh man, let's put like a little bit of green. 0, 8 green. It's just, I don't know, it's a guess. And then an equal amount of blue. That's pink. Fourier transforms the change of basis on function. Yes, sure, whatever that means. So B were both too high for red. 0 needs to increase. It can't be that much. Let's put like a 2 for that digit. 8 needs to increase? Wait, does this mean go lower or it is low? Am I flipping this? It might mean that it is low and need to go higher. That's a good, okay. Let's go like DD, double D. Wait, but 0 can't be too high. No, it has to be the reverse, because if I'm getting an up arrow on 0, I can't go below 0. Yeah. Oh, you're right, there are 2 arrows, so let's try like 9, 9. And let's try a 2 in that spot. A C in that spot. The B goes lower, so I'll put a 9 there, and that B goes higher. So I'll try a D. That's not too far off, but the 2 is right. 9 needs to go a bit lower. Wait, I mean, I don't know the scaling here, Jed, if it's how much 2 arrows exactly means. Try like a 7, 7. 2 is right. C needs to go higher still. Much higher. So let's just bump that baby up to F. Put a 7 there. And the D needs to go higher still. It's either E or F. Why not F? At least go E? Oh, true, so we get more, like, resolution. Oh! I would have been right, Jed. How dare you? I would have gotten one less guess. Oh, the music! That's a fun puzzle. Thank you, Mangoes. That's the link for it. 69%? Hell yeah. I have done Nerdle. Nerdle's pretty fun. Not doing that. I'll get back to this once there's a break. So Syntax posted a question. And hey, Humaira, over on YouTube, I see you posted something that you retracted. Let me know if you have anything to ask. I don't think I have any pending questions apart from syntaxes. So let's bring it up. Oh, this looks terrible. Oh my god, what are you doing to me, Syntax? Yeah, Maxi. It's make it funny. I'll take a look at it. I love Nerd. I got banned for doing 6th grade because you were too good at it. You left in a mistake. A weighted Fibonacci sequence. Oh, okay. I only saw like this thing here. I thought it was gonna be like some like messed up derivative. So A, B are the weights. Yeah, there's very few numbers on this page, Waffle, you're right. What the hell's a way? I would need to like try this with some A's and B's. To see the effect of the weights. You left in bar times I twice by accident, somewhere around here. Okay. The second was unnecessary? Okay. I is the limit of the n plus 1th term over the nth term. And we're subbing for the n plus 1. Get a cancellation. And then well, this isn't quite I, is it? Isn't it I with some constants? Oh, maybe that's where the constants are coming in here. Okay, yeah. The notation is a little bit weird there, but I can see how you get to this step, I think. You multiply everything through by I, you get a quadratic. How do you have more than 2 weights? Does that mean the recursive definition changes? Like you have plus fn, or like, plus c fn minus 3? Okay, yeah. We add more terms. To which option does it converge and under what conditions? Yeah, how do they distinguish that for the regular Fibonacci sequence? Fibonacci sequence limit. Wait, I mean, shouldn't it be the golden ratio if the weights are 1? Or does the golden ratio come from somewhere else? Okay, yeah. So I assume that we could look at that case and try to inform this weighted case. Well, I mean, wouldn't that force a choice of plus, or could it depend on the weights? Because you get the golden ratio from the plus case, do you not? Hmm. They don't actually solve the quadratic that you get from this, though. Oh, okay. I remember you mentioning about finding ways to compute square roots. Really? They're really skipping over the part that we want to know about here. Underscore. Are they just doing it numerically? Like, how do they know here to take the plus? Underscore, basically the question is for the Fibonacci sequence, if you prove the limit of the ratio of the terms in this way, when you get to solving this quadratic, how do you know to take the plus from the quadratic formula rather than the minus? Well, the minus case is below 1, and it's certainly an increasing sequence. That might be the... Oh, we don't know that here, though. Am I on Instagram? No, I don't have an Instagram, sorry. Minus is negative? No, it's not. Is it? Oh, maybe it is negative. Root 5. Oh, yeah, it is negative. You're right. I thought it was just 0.61 with like the 1 chopped off. Oh, that makes sense. Are you on Snapchat? Oh, no. I technically have a Snapchat from a long time ago, but hell if I use that. So that's a conundrum. So where this comes from is syntax is looking at this weighted Fibonacci sequence business and is trying to make the same choice of the positive or the negative root. It's not as clear here though, because you could jack up your B and have a positive number for both. Can you, or, well, no, you would jack up your A. Well, or can we prove it? I mean, you're testing it's always a positive, but you can't really justify it. Number approaches 2 from below. Interesting. I'm just curious what Wolfmouth would do with this. I know, it should just be 2, right? Yeah. You get a hyperbola of solutions where, like, you know, everything to the right of the hyperbola could be... Okay, there's definitely combinations of A's and B's where this thing is positive. That's what I guess what I was trying to get out of this. And yeah, if your A value is high. Oh, really? Fibonacci? Oh my god. Tetranacci? Yeah, Fibonacci is a good name. Fibonacci word? Oh god. You're saying higher orders for a source. I missed it, evidently. Oh, you just higher orders. Okay, I don't know how to read. Are you saying under Tetris what you want to see? I mean, I think these are Infinacci? Oh, well, this isn't weighted, though, necessarily. It might have something helpful for you somewhere in here. But yeah, I'm not sure I have much that I can help you with here. Syntax, I'm sorry. Let's say there's something on this page that addresses it, but I don't really see it. Oh, is there a mistake? Minus b, which is positive a. Oh yeah, this should be a squared plus 4b. Yeah, Bluebird with the saves. Oh, I don't know if it's pronounced Felipe or Felipe, but a student from Brazil. I noticed, and I clicked because I saw the NCR flag on the wall. Awesome. Yeah, I love Fallout New Vegas. Would that make it easier to analyze? Oh yeah, and a squared, the square root of a squared plus 4b is clearly greater than a, right? So the negative one is negative, or the minus one is negative. Wait, minus b plus or minus the square root b squared minus 4ac. I'm pretty sure that the a goes here and the b goes here. And that'll make it a lot easier to chop off the minus case, because that one was just negative. Thank you for checking that, Luberd. I should give out some saves for that last question too. So I always forget to give them out. B and A, they don't both need to be positive. Oh, you're allowing negative weights as well. Oh, crap. I feel like usually when I see weights, they're positive. Okay. I mean, that throws a whole wrench into things. I don't know about that, but I actually pointed out a little mistake. Hey, Phobos. Okay. Is there another question that I'm forgetting? Should be enough for the square root thing. Okay. I think we'll get back to doing Penn Center's midterm here. Because I don't think there's another question from the chat right now that I see. So we just said 1A. Actually, let's check my answer. So I got the same exact number right back out, which is funny, but entirely possible. Okay. This is more helpful to me than this, but yeah. Okay, so let's look at part B. Now, we have 2z2 plus z1 minus 5 minus I squared. Well, like that squared. 2z1 minus z2. Plus 3 minus I. Now, I assume there's a way to make this simpler without doing a whole mess of algebra here. Let me see if Penn posted something with like the properties of I guess we want like the modulus of a complex number. I don't think I want that page. I mean, it's not that bad to just get through the arithmetic here, right? I think we could split the modulus up on the fraction, right? Like we could do the modulus of the top and the modulus of the bottom. Or not. Wait, this is modulus or, yeah. I think the bars are modulus. I still feel like there's some kind of simplification that we could make to make it easier, but we could also just bash our heads against the problem too. And also get the answer. 2 plus I. 4 plus 2i minus 3 plus 2i plus 3 minus I. All right, 6 plus 2 minus 5, 3. Minus 4 plus 1 minus 1 is minus 4. 4 minus 3 is 1, plus 3 is 4. 2 plus 2 minus 1 is 3. I don't actually know about that distributing the modules to the top and bottom thing. I'm going to try it both ways. And see if I get the same answer. So doing it the long way that I know will work is multiplying the top and bottom by the conjugate of the denominator. $12 minus 12? Really? I think so, yeah. And then minus 9i minus 16i over 16 minus 9. Am I going to run out of? No, I'm good. I guess these have a symmetry. It's really weird to me that the 12s cancel. It makes me uncomfortable. I think that's just what happens, though. Yeah, this is from Penn's midterm. Now, if we just have a purely imaginary number, this can't be right. Like, the modulus is just that component. This feels wrong. Those are just weird numbers, right? I feel like I made an arithmetic mistake or a copying mistake. Top is bottom rotated 90 degrees clockwise. Oh, is that the trick underscore? Philippe says, I'm going to go now. Have a good one. Awesome. Well, thank you so much for stopping by. These two are just rotated by 90 degrees. They do both have a I guess like hypotenuse 5. So doesn't, if they're both just rotations, like shouldn't I be getting 1 if I'm dividing the two? I definitely made a mistake. This is not even slightly to scale. So that's what I was wondering, I guess, like, could I take the mod of the top separately and divide it by the mod of the bottom? Or magnitude, or, you know, whatever you want to call it? That's what I was going to try, like, doing both ways, because I wasn't sure. But, like, this should get me to the same result also. 12 minus 4i times minus 3i is positive 12i squared, which comes back around to negative 12. 3 times minus 3i is minus 9i. Minus 4i times 4 is minus 16i. Here you get 16 plus 9. Who even likes I squared, man? Okay. And so what's the geometric interpretation of dividing two complex numbers? I guess would you be subtracting their angles? Oh yeah, that's why we get something that's right here, because we're backing up 45 degrees. Well, not 45 degrees, but however many degrees this is onto the negative imaginary. Huh. Okay. Oh yeah, thank you, underscore. Yeah, Thunder, this is the midterm for Penn Center's complex variables class. So someone decided to do today just like a little like filler while there's downtime. Yeah, Zach. It's got their 1B here. So let's look at, I guess, 2A. Well, let's look at B like on screen as well. Me as well. So we want all values of z that satisfy e to the 4z equals I. I think it's worth it to convert I into polar form, right? E to the I pi over 2? Am I crazy? I think that's okay. Because cosine is 0 and sine is 1. So yeah, this seems reasonable. And then we can take... There we go. That'll get us what we want. Now we just divide by 4 and we solved for z, right? Let's do some test values. So e to the... Oh, wait. Forgot my I. So e to the I pi over 2, we already said is I. Then what's the next? If we take k equal to 1, we get 5 pi over 8 times 4. That doesn't... Well, 5 pi over 8 times 4 is 5 pi over 2. And 5 pi over 2 is just pi over 2. Okay, yeah. Yeah, I remember the I. Now we take the log on both sides. I mean, I guess I did take the log on both sides, just not the capital L log. Part B is a quadratic with z's. I think the quadratic formula still works, but I wonder if there's like a factoring way. Goodbye, marker. Can we name a number that multiplies to I and adds to 1 plus I? Kind of what I'm curious about. Or I guess two numbers that multiply to I and add to 1 plus I. Oh, isn't it just 1 and I? Okay, well, that could have been harder. Well, there might be a trick here that I'm gonna miss, but are there more solutions than just these? Let's plug -1 back in just to see. So that's 1, -1, minus I plus I. So that works. Negative I squared is -1 still, right? Yeah. -1 plus 1 is 0. Wait, no, that's not, that's a minus I. The minus I plus the I is 0. That's... how about this? So let's just keep it as I squared minus I squared, and that's 0. Okay, so those two both work. Quadratic implies only two solutions? Okay. Well, I'm not going to expand like that. Let's just expand like this. Well, okay, let's just expand the entire thing because it's like a discussion one. So for 3a, the fallacy here has to be in this step. And this particular exponent identity, I can't imagine is defined for negative numbers. I wonder if that had a name in the class that I should figure out. Okay, I don't see that part in the class where he would have done this. Wait, what the hell? That's not what I want. Week 1, class 2. Is there anything in this one? Okay, fine. Who cares? I'm just going to say, I'm pretty sure the issue is that you can't use this exponent identity with the square root of -1. I can't imagine it's defined for that. Explain why we suspect the series from n equals 1 to infinity, or the sum from n equals 1 to infinity of I over 3 to the n minus 1 is convergent, and find its sum. Well, it's because it's a geometric series, and well. All the I to the n minus 1 is doing is rotating you 90 degrees with each power. The thing that's making this converge is the 1/3. That's making the numbers get smaller each time. That being said, when we go to find the sum of this thing, do we include the I or do we throw out the I when we plug it into the formula? A over 1 minus R. I remember seeing him do a geometric series somewhere. Maybe it's in this class. Ooh, I see it. So it's an open notes in the midterm. So we have nearly the same thing as, oh, that's just discussing the sequence. Do they talk about series at any point? I mean, we could still apply what we know about series and what we know about what the I is doing here. Okay, yeah, that was my answer to Milk. That we're not allowed to do that with a negative number. I'd love to rewrite this series here in something that very obviously matches. Okay, well, I mean, I can kind of do that. I wish there was a little bit cleaner way for me to figure this out, but... Oh, hey, Pen. To know more about why. Because Wikipedia tells me so. It's a perfect answer. It's the source of all knowledge. So the first thing I want to do is, like, I think the typical geometric series starts from 0. Otherwise your formula gets a little messed up. The first exponent is 0 anyway, so I think without doing too much harm, we could also say this. And I like my idea is that we can split this up and make the claim that, or, you know, we know that n equals 0 to infinity of 1/3 n is geometric and convergent. And this bit here rotates 90 degrees. That's all it does, it doesn't actually affect the actual sum. But I'm trying to like put that together to get the actual value of the sum. Come out of your incognito mode. I bet you could refer to the complex function square root z or z squared for inspiration. It only holds because you know, this is bad. I missed a few of those earlier classes where you would have talked about this. It's for like part A. So my answer to part A was basically just what Milk said. But if you're looking for something more, it's you're saying the complex function square root of z or z squared for inspiration. Oh. I think I might see where you're going with this. -1 is equal to I times I. Like trying to mimic that same line of logic, but with i's? Or, well, but now if we look at square root of -1 times square root of -1, this would equal 1. Which is not equal to I times I? Is maybe that? Well, maybe that's not the idea that you're going for. I thought I saw it for a second. Does it mean take the square root of -1 equal to I? That I squared equals -1? Ah. I need to figure out how to turn off that hotkey. My hotkey to turn my cam on and off also switches the tab in Firefox. Why do we pick the square root of 9 equals 3 and not -3? To make it a function that's like well-defined, or I guess like, maybe not well-defined is the wrong word, but like single-valued. Or maybe, I guess well-defined is still a good term. Well, I guess I don't see the connection there, though, because are we saying that we're taking... we could have chosen I to square root of +1? through the concept of branches. Crap. That's what I get for skipping class. Oh yeah, underscore. This is it's probably it's at a terrible time for you, but Penn Center's been doing an actual like complex variables class for his college that he teaches at. So there's actually students that are like taking it for credit. Hmm. As I'm still having trouble with how this exponent distribution idea leads to branches. Oh, branch cuts. Oh, that's right, with the argument function. Okay, I remember like branch cuts being talked about in that context. How many branches does the square root of z have? I guess it must be 2 branches. Like we could define it, I assume in quadrant 2 and 3 or 3 and 4. It might be like 1 and 4 and 2 and 3 though. Still. Or you probably define it like in any rotation of those, but when you write root minus 1 to mean the principal branch. I mean, yeah, I guess I'm gonna have to think about it more because I'm still like, it's still weird how it relates to that distributed property of exponents. I guess I just need to keep thinking about it. Are number of branches independent of where we choose the branch cut? Play some branch cut games to confuse Dawn. Right. Underscore. Hmm. Okay, I mean, and then I guess going back to part B, I still don't have a good justification for it. But I feel like you could say that the sum is still a over 1 minus r. But having an I in there kind of makes me uncomfortable, but I feel like it's what you're supposed to do. Like, this should have a complex sum. I guess. Sure, critical. Business to the fallacy, according to branch, happens in the second equal. You basically... Right, yeah, so as soon as I saw this problem, I knew like it'd be somewhere in here, but like explaining with branch cuts is still kind of weird to me. Once you cross a branch cut. Okay. I guess you've implicitly crossed a branch cut there. Okay. Reduced echelon. Others and oh god. Did we say the difference between reduced echelon and just echelon? I don't remember it. I can see that I've Googled this before. I think reduced echelon has the ones for the pivots. Inverted staircase for the zeros. It's the only non-zero entry. Okay. Reduced echelon, only an echelon. So I think A is reduced echelon because you have that lower left triangle and this one the column is only zeros, so I think that's reduced echelon. B, I think is also reduced echelon by the same logic. Milk is claiming that C is neither. I assume this two ones are messing it up. Can we, so the instructions make it a binary choice though. It's either reduced or regular. Is this regular echelon form? It's really not though. There should be a row of zeros on the bottom. B and C, or maybe this is echelon form if that's the only. I hear there's like some kind of technicality with the definition here. Okay. Yeah, C violates this one right here. Yeah, yeah. That's weird. The instructions. Okay. The instructions don't make it clear that neither is a choice, but I think C is neither. And then D, I think we can say is just echelon form. So A, B are reduced, C is neither, which makes me uncomfortable, and D is regular echelon. Can I just get rid of the column when it's all 0 and assume that it's echelon form? Oh, in part D here? Neither of, yeah, basically. Neither definitions care about having that column of zeros. Yeah. It's not the redundancy, it's the lack, it's that these are 2s and that's a 3. That's what's breaking the reduced part here, I think. Yeah, and like Penn Center is saying, the zero column does have significance for other contexts. For the sake of like only figuring out reduced versus not reduced, it's not too important, but it is in general important. Astrophel, thank you for the follow. Oh, are you 900? I don't know if I was on 8. Oh, you're 900. Holy crap, thank you. The number just updated for me. I read that as 900 factorial, and I was like, one day 900 factorial. You're still at 666? Hey, that's a good place to be. When we have redundant rows, what do we do with it? Like, are you asking how would you reduce C if you wanted to get the reduced row echelon form? Oh, I get it now what you're saying, Jet. You said Sparta 3 times because 3 times 300. I was trying to work that out. It's clever. I mean, C is weird. I realize the instructions don't give you the option to say neither. But unless you're using a different definition of echelon form, Jed mentioned it? Oh, well... Yeah. So at least looking at the Wikipedia definition here, for just row echelon form, it violates this condition here. And what it's saying is that each pivot can't have anything else in its column in order to be an echelon form. So or like, it's on the right of the leading entry of the row above. So these two, this is where the issue happens for echelon form. Like, in the second row, this is it would be the pivot for the second row, except there's already a 1 above it. It's not to the right of the leading digit for the row above. Like, this 1 would have to move off to the right here, but that would also cause issues elsewhere. But it's these two ones on top of each other that make the issue, where these both want to be pivots, but they can't. As far as I can tell, it's neither, yeah, critical. Oh. Yeah, as Milk said, you're gonna have 3. Like, you can zero out one of these first 2 rows here, and then just transfer it to the bottom and move all the other rows up. Not until you swap the rows, Jet, I think. I don't see the exact condition in Wikipedia, to be honest, that would address Jed's question. I thought you do have to have the 0 rows on the bottom. It has to be in row echelon form. And does row echelon form... Oh, okay, yeah. It's because it has to be in row echelon form, and row echelon form requires the 0s at the bottom. Okay. Opinion without 3.14 is just an onion. It's funny because that joke only like half works, I think, but that's I think it's funnier for it. Eldritch. No worries, critical. And hey, Mr. Suraj Chubi? Oh, Asherpel, is that you who posted a problem in the Discord? Oh gosh. This joke is like an ogre, it has layers. And so the actual question, I had some trouble with the heredity part of this inequality. I'm not sure what the heredity thing means. Oh my god, it's a product of factorials. Until we meet again, alright, Eldritch. Thanks for popping in and dropping that joke. That's true, Jed. They are both product of factorials. Uh... Hey, Anders. So, have you already gotten us started on this one, Ashrafel? Like, I assume you have to do something with induction here. I assume that's natural numbers without zero, which might already be automatic for a lot of people. But I assume it's n equals 1 and on. Why do you love math? It's a good question. I just enjoy the connections that math can make between the connections that the math can make in other like fields of study. Tell me the secret to master in math. Oh, I haven't mastered math for myself though. The kind of the unfortunate answer is that it takes a lot of grinding. Like you just have to drill through a lot of problems, for me at least. Having a good teacher can really help, but if you can't always control if you have a good teacher or not. The best thing you can do is just not be afraid of it and just try and like be okay with making mistakes and not doing problems right the first time and just keep on trying. Hey Joseph, and hey to 7 more. So we can try to set up an induction on this. I don't really know. So I assume that you can be set up the induction, you're having trouble with a certain part of it. I got that mixed up. Why are the brackets in there? For the product, I'm not sure. I mean, I guess the factorial. Yeah, that's probably what Jed said, I think. When k equals 0, we have one factor. What am I writing? 1 factorial times 3 factorial, which equals 6. 1 plus 1 factorial to the 1 plus 1 is 2 squared, which equals 4. 6 is greater than 4. Okay, the base case checks out. Technically, we should make that n some other number, but I'm always too lazy to do that. Okay. Mr. Suraj. I'm doing graduation in India and the math are advanced. I always learn math from YouTube. Yeah, YouTube is there's some really nice YouTube videos out there. It's an inequality, which means this induction is probably going to take some really creative step here, or it's going to require something creative. We can start with the left side here and split off the n plus 1 factor. Well, let's put it in front to make it clear it's not part of the product. K equals 0 to just n. And we know from the assumption here that this expression should be greater than this, I guess times that though. Maybe that's not so bad. Well, yeah. Let's also simplify the 2n plus 1 plus 1. Maybe, Jed. I don't think it's important enough to include it. Or I'd say it's obvious. So now the task, I think, is to basically bridge the gap from here to here. We want to show that this thing is greater than this thing. Ideally. Or equal to. I doubt it's equal to, but it'd be nice. So well, that n plus 2 is ruining everything that I want to do here. What I want to do is say that 2n plus 3 factorial is more than n+1 factorial. And then I could bring the n+1 factorial into the exponent here and get the n+2. The 1 versus 2 business isn't quite right, though. That was your idea, too? An n+1 factorial, the leading term? Oh. I guess so. Or, well, When I was, you can find an n+1 term in that 2n+3 factorial. I don't know what that would mean for the rest of it, though. It's a really tough induction, Thunder. That, you haven't seen before, this thing is capital pi, and it means, it's like summation, but instead of adding it, you do multiplying. You writing something quick? From there, I just ratio the right-hand side with n+2 factorial to the n+2 and show it's bigger than 1. And from there might have meant the step before the last one that I just put. Oh wow, do you write that quick? Let's see. Just, I assume that I can show those. I don't see any identifying information here. Is this the right thing? That's just lorem ipsum. Oh, okay, I wasn't sure. It's the very bottom of that list, text 12. Okay, yeah, I see it. Oh, I guess I need to compile it. Don't do that. Yeah, sorry about underscore. If there's a way to like kick me out, feel free to do that too. Okay, so we agree up to here. Now you're claiming. Okay, you're splitting up this into 2n+3 times 2n+2 factorial. Oh, maybe that's what Jed was saying instead. I might have misunderstood. And then you're splitting the 2n+2 factorial out until you get to the n+1 factorial bit. Sounds good, Thunder. And then you're taking this last line here and dividing it by n plus 2 factorial to the n plus 2 to show that they're equal? Because you get 1? What? How do we bridge that gap? So all it's changing in this step here is oh, okay, you're right. There is a greater than. You're going from this denominator to this denominator within equals. N plus 2 factorial to the n plus 2 is apparently equal to n plus 2 to the n plus 2 times n plus 1 factorial. Oh, so from all these n plus 2 factorials that you have n plus 2 many, you almost like you factor out the n plus 2. N plus 2 many times. Okay. And then you say this, oops, then you say this stuff here is all greater than I assume this is n plus 2 many n plus 2s. Yeah, this chunk is certainly, I think it's only, is it n plus 2 many things? Oh yeah, okay, these two cancel. It's whatever the same, well, it is important down here. Okay, so yeah, this is n plus 2 many things in here. Wow. Why to show that it's greater than 1? So it's a clever technique that I would not have thought of, but we're trying to compare the thing that we ended up with here with the original thing that we need to get to. So if you take this number, or if you take a number divided by another number, their ratio says something about which one is bigger. If you take a small number and divide it by a big number, you get something between 0 and 1, a decimal. If you take a big number and divide it by a small number, you get something that's more than 1. And it's the same exact logic applied here with these complicated things. Yeah. And it's tricky because there's another inequality involved. So what underscore really showed here is that the numerator is greater than the denominator, not the same. Right? Yeah, underscore is really good at math. And basically this is justifying, like, you could add on one more step to make it really explicit here that this is greater than this, and that's your, you know, you've now bridged the gap from this being greater than that. I'll try to get the entire thing in one like window if you want to take a screenshot or something there, but underscore, you did that quick too. Nicely done. Yeah, that's not an easy question at all, Thunder. Actually, I'm gonna take a screenshot of this for myself and put it in that Discord thread. Minutes before you start. Oh, okay. I mean, that's still pretty dang quick, though. All right, Thunder, I'm switching over to yours right now. Given that y is a function of x, show the second derivative of y squared is equal to 2y d squared y dx squared. Hey, negative plasma. Yeah. I don't know if I told you that day, but I do have like my math days and my gaming days, so my math days are Tuesday, Thursday, Saturday. Sorry if there's some like confusion there. Oh, okay. I was getting a little bit mixed up with why we're getting the second term for part A, but I think I see what to do now. Okay, so the important thing to remember here is that y is a function of x. And so we want to show two y okay. Y equals y of x? Yeah. In chain rule, yeah. Okay, so let's start with the left-hand side. And they want the second derivative, but let's just take it one derivative at a time, because the second derivative like this is the same as d by dx of d by dx y squared. So let's just evaluate the inside bit first. So that outside d by dx will stay there. Inside, this is called implicit differentiation. Because y is a function of x, we're deriving it with respect to x. So I don't remember if you know implicit differentiation. Sardan, thank you for the follow. You think you do? Okay. Well, basically the idea is y is a function of x, so if we take the derivative with respect to x, the procedure is basically, you can treat y almost like it's a variable x, so you apply the power rule here to get 2y, but because of the chain rule, you do have to multiply by the derivative of y with respect to x. Because, let's just pretend that like y equals sine of x, just as an example. That means y squared is equal to sine of x squared. So we definitely know that because of that squared, we have a power rule somewhere in there. It's like, it's definitely going to look something like this. But because of what y happens to be here, sine of x, there would be like a chain rule, like times cosine of x. This cosine of x, or the dy by dx represents the cosine of x in this example. That's probably more than you need to know. Basically, if you take the derivative of a y, you multiply that dy by dx. So you're saying, yep, so I assume you get this. And so that's all we get for the first derivative. In dy by dx, if it's easier to look at, you could also write y prime of x, or just y prime, if you care to. This is just another function in terms of x, is the important part. So now we can go about taking the, we can deal with that outside derivative. Thing is, we have a function in terms of x times a function in terms of x, so now we get a product rule. So I'm going to start by taking the derivative of that 2y. So 2 is just a coefficient. When you take the derivative of y, it goes to 1, but because of that same chain rule, you multiply dy by dx. And you still have that original dy by dx too. Now for the other part of product rule, the 2y will stay the same. I'll take the derivative of dy by dx, which is just d squared y. You know, if you take the derivative of a derivative, you get the second derivative, or y double prime, if you want to use that notation. Dy by dx times dy by dx is dy by dx squared. So that's, I think that's what they call it for, right? Yeah. Does that make more sense? Mr. Suraj. I don't quite understand what you're saying there. Are you talking about the problem that we're working on the board here? So this is a downfall of the Leibniz notation thunder. When written like this, it's a second derivative, which is completely different from the first derivative times the first derivative. But they do both look like exponents. These are completely different things, though. I would rewrite this with primes as like, if I could write, I would rewrite it as 2y prime squared plus 2y times y double prime, if that makes it more clear. Yeah, that's what I was like trying to show an example with the y equals sine of x thing. To be honest, I did just accept it for the longest time, and I randomly realized one day why you do that. So if you do just remember that you multiply the dy by dx, you'll get the right answer. So as I'm showing an example, I don't know the best way to really like say it, but like if I do like try and explain the example that I showed more, if we imagine that y was sine of x just randomly, that means that y squared is sine squared x. And if we take the derivative of y squared here, well, like when we go to take the derivative of y squared here and y is something generic, we know we're going to have a power rule with this 2 coming down out front times the original thing of whatever y was. But because we don't know like what's kind of inside there, like, you know, we would, taking the derivative of this, we would get the cosine x from the chain rule here. But when we just have a generic y, when we don't know what it is, instead of having a cosine x there, we have a dy by dx. And that's just a y. So it's because like we don't know like what to fill in here inside the parentheses, basically. We need to be safe in case there is a function here and multiply by that dy by dx. I hope that kind of makes sense. Oh no, you're still lost? Okay. That's completely fair. Hey Krish, I'm doing well. How about you? How can I explain this better? I've been doing the derivative on y squared. Preparing for the examination? Oh, well, good luck, Krish. So, this came up because we had this. We had to evaluate d by dx of y squared. Y is something involving x's. It could be something crazy. It could be something simple like a log or a sine or a cosine. It could be anything. All we know is that we have that squared on the outside. So we know how something squared derives. Like we just apply the, like if you have anything we want with x squared, we always know that we can take the exponent down and subtract 1 from the exponent. So just y represents something in terms of x. But we don't know what that something is. There could be something with a chain rule involved in there. So that's why like we have to cover our bases here and multiply by dy by dx, because that's just whatever the derivative of y is with that squared removed. It's like that y could be, you know, if you have like 1 plus 2x squared as an example, we know from the power rule this 2 comes down out front. But we would get the wrong answer here because we get something from the chain rule here from the 1 plus 2x. We have to add on that times 2. Multiply that times that 2. And because there's that hidden like 2 from inside the function, like we have to cover our bases with the dy by dx there. Like that's what we mean when we say the chain rule. Okay, yeah. Oh, does Black Pen, Red Pen have a video on that? Do you want to talk about part B as well, or is it just part A? Do you think you improve chain rule from the difference quotient? I don't remember. What was the difference? I think I had to prove, we proved the chain rule as part of Zach's analysis class. You got part B? Okay, cool. Yeah, maybe the 1 plus 2x is a better example there. All right, see you, Mr. Suraj. Thanks for being here. And I remember doing the product rule, and you have to do some like kind of crazy plus minus thing. Kernel's easier if f is injective. Mr. Suraj, I think you maybe misunderstood the question. Like, this one wasn't to solve for y. It was just to prove this equality. I don't think you need to integrate anything. If G oscillates near A. Oh, this is like, this is a more technical proof than would probably be expected of a student doing analysis for the first time, but... Ugh, I'm sorry, I don't feel like looking at this. Okay. Yeah, the Discord quickly, okay. That's before true calculus, you prove chain rule with the product of two fractions. Is true calculus analysis? Oh, we gotta show and tell. Oh, with like differentials? Huh. Okay. Show and tell. Okay. This is easy. I used to be very into paintball. In high school. Oh, it's been a long time since I've taken this thing out of its case. And let me there was one summer in high school that there was a professional paintball tournament happening down in Huntington Beach, which is in Southern California. We went down and saw it. And this was my favorite barrel that I was using on my paintball gun, but as I felt really hyped in the moment, and I got Dynasty, at the time they were the best professional paintball team, I don't know if they still are, to sign my like barrel. So from years ago, this is signed by like every member of the team. I spray painted it with lacquer just to try and preserve it for longer, and I have it in the original like tube that I bought the barrel in. But yeah, I would want to like bookshelf, just like a little memory of being into paintball at that time. I sold off my, like, I had a really nice paintball gun that I kind of regret not keeping, even though I wouldn't really use it. It was just such a nice, like, looking gun. I had a couple of guns, but there's one in particular that I regret, like, not keeping. First time I've seen you without headphones. Oh, yeah. Teacher in third year at university tried to prove this way. I was legit mad. Why does it seem without glasses? That's when things get really weird. Your brother used to play paintball. I never did though. Oh, interesting. It's pretty expensive, but it's really fun. Oh. The canceling differentials thing. Friends rather play Valorant than do IRL paintball. Dude, I kind of miss playing paintball, but the reason I stopped is that my friend group in high school that I would play paintball with kind of like just blew up with a frickin' drama, basically. I never got like a new friend group to get back into it with, so what are you gonna do? Did that start already? Okay. Can we safely do e to the power of each side here? Because pi over 2, like, it's on the same branch, is it not? So I don't think there's any worries about making this statement here. And then we could take z equal to re to the I theta. And how do I want to deal with that 1? Oops. We could say that this is e to the 0. I0 even. And then, is that really necessary though? Oh shoot, I mean, dude, the +1 is so annoying. Maybe I should not do it in polar form. Because that's just I, right? Now we could do polar form, that might be simpler. I don't know if you can just, well, you could just take the square root. Well, you still have to do the square root of that number, I guess. I don't know if that's faster. Wrong. Three pi over 4 is the angle we want. Calculate with his fluxions. Same way what Leibniz did. Ooh. So now to get r squared equals root 2 and e to the I2 theta equals to the I3 pi over 4. So r is really, oh, I guess we need a plus or minus. But the 4th root of 2? This doesn't feel right. I guess we could plug it back into the original. check our solution. We already said that this is equal to -1 plus I. So do we get I pi over 2 from this log? Oh hey, that does get me the original answer. If I didn't mess up too bad. The negative would work the same. So I guess our conclusion is that z equals plus or minus the 4th root of 2 e to the I 3 pi over 8, annoyingly. Maybe that Wolfram would do this. Is there more than one principal square root? Or is it the one with the smallest positive theta? I mean, I thought when we get to the r squared equals root 2 scenario, that's just a real number problem, is it not? I think both solutions work in the original. Is one not in the principal branch? Oh, maybe that's what you're saying. Is the minus or the plus case? Well, no. Well, so the angle is definitely between minus pi and pi. I assume the negative in front doesn't mess with that. Do you just need to rewrite the -1 e to the minus I pi? What's wrong with converting -1 plus I into a single e? Return, oh. Let's see if we can find it. Oh, R is positive. You're right, Cook. Yeah, I remember, now I remember us defining R to be positive. So it should chop off that negative solution. Hey, Suna. Yeah. Oh. Take off a negative, but adjust the angle. Oh, you know what? I forgot about that bit in there. But I don't know, would have really helped, I don't think. Hmm. Well, yeah, I mean, what we would do is we'd do like, to fix the minus fourth root of 2, leave a vector pointing at, it's basically the same as minus 3 pi over 8 angle. Hey, Sergeant Duck. I don't think we are fine. I don't see why it would be fine. Wolfram Alpha also gets just pi over 8 rather than 3 pi over 8. Which is also concerning. But like minus 1 plus I is just 3 pi over 4, is it not? How would we possibly get just pi over 4 there? I mean, I think the fix is actually pretty simple because of the way the domain is constructed, or the domain of theta. Instead of doing plus or minus, you just put the negative sign up on the angle. I don't think you have to think about it that much harder. Oh, no, you do have to think about it harder than that. Do you? Yes, you do. Why can't I grab my marker at all today? I still hate that I have a 3 and Wolfram doesn't, but... Well, 3 pi over 8 is nearly pi over 2. So we want that angle right there. measured from here as a negative angle. But wait, so that is, no. We want to add pi, the entire angle is pi minus pi. Take out 3 pi over 8. I think that's what we want. That looks right. So that would be adjusting the answer that I got. So yeah, I mean, I'm satisfied with my answer, except that Wolfram Alpha. I'm trying to figure out if this is really the same answer or not. They're just using some weird identities, maybe. It's weird because this, oh, well, I mean, it's not really that easy to see. Like, the graph they have, like, this is clearly not pi over 8. So I'm a little bit confused by what Wolfram Alpha is smoking. I don't know. Okay. That'd be great if Wolfram Alpha was using a different principal branch. For part B, I'm going to have a separate problem, which is I didn't see the class where we discussed analytic functions. Is analyticity like the hardest word to pronounce in math? I'm looking for whatever class section that was on. I could bring in the book maybe too. Sermon definition. Might be in this one. Let's see. I should probably just bring up one of the initial PDFs, right? Aha. I found it. Week 2, class 2. Okay. complex function is entire if it is differentiable in the entire complex plane, and analytic in an open set D if it has a derivative at every point. Oh, it just has a derivative on a domain that isn't, well, it could be the entire complex plane also. It's analytic if the derivative exists there. And we know whether it exists usually, but not always, from the Cauchy-Riemann equations, I think. Right, don't worry, I think I was like a question at one point. I don't remember what the answer was. I do need the class notes here to figure out what goes in those. I mean, I could follow along the thing, but I'm not going to. You know, I guess I just wasn't paying attention in class notes because I do remember seeing this fill in the blank format. Where does that happen? Wait, I'm not looking at the right class. Wait, I should be looking at the right. Am I not looking at the right class? Week 3, class 6. Is it this one? Almost there. Found it. Okay. So u sub x equals v sub y, and u sub y equals minus v sub x. And yeah, this is for a function that you can express as a real part in terms of x and y and an imaginary part in terms of x and y. So the question was, determine where f of z equals log 4 plus I minus c is analytic. Find f prime of 2i. So I assume we want to split z up into a plus ib and get a real part and imaginary part. I cropped the previous probably accidentally. Wait, what? Okay. We don't even need part A or the intro, I guess, here, but it doesn't matter. Oh no, all that was just figuring out what analytic means. Why am I doing this? For a reason. 4 minus a. Is there an easier way? Probably. But I'm doing it like this to convert this thing into polar. So that way we get this. It's just I theta, isn't it? Yeah, because the E. Okay. And this is something that we can do something with? Oh, thank you, Lubird. That's the explanation. Okay. I appreciate it. Wait, did what I wrote right make sense? Oh yeah, it's u sub x equal u sub v, but I have a and b, and I should have put u and v there, but it's too late now. So, oh god, I'm gonna have to translate how we wrote the Cauchy-Riemann equations in the notes. U sub x equals v sub y. And u sub y equals minus v sub x. But instead of x, I have a. Y is b. Y is b. How is b? Okay, those are the partials that we want. That's annoying. What? There has to be an easier way than what I'm doing, right? These are some annoying partials to get. Should I be... Have we stated somewhere where log... Or is there a more general way to figure out, like... Or maybe we've already figured out where log is analytic. And it's just a matter of transferring that knowledge. Yeah, I remember us doing something with expressing a function in terms of only z and z conjugate. And looking back through the notes. This might be something. I don't remember. It looks like figuring out where the Cauchy-Riemann equations hold here. I think we just use this, don't we? Okay, so let me figure out this last little bit here, critical, and then I'll take a look at yours. So yeah, when I first saw this, I immediately threw out like, you know, where a branch cut is mentally. So I think we're maybe not analytic if z equals 4 plus I, and we're not analytic if theta equals pi, because the pi is inclusive, whereas the minus pi is not inclusive. Oh, I'm right? Okay. And yeah, even then, you repeated the definition there. But yeah, okay, I was doing a bunch of extra work for no reason, because I forgot that we did it in general for a log in class. F prime of 2I. Where do we actually get the derivatives? Like, the derivative of f with respect to z? Over z. Just hold. Okay, cool. Yeah, I can never pretend that z is a real number and do the usual procedure. I just was looking for a justification for that. Or I don't know what else it would possibly be if we don't get to do that. And then once I do this critical, it shouldn't take long. I'll look at your question. Is 1 over 4 plus I minus z chain rule times minus 1. So I'd say that f prime of 2I and just to be, you know, an overachiever, let's rationalize. I don't know if it's an overachiever or if that's just expected, but I'm going to do it. $17? Ew. I don't like 17. But oh well, that's what we get. 17 is the best prime? Okay. if I get 17, I kind of assume that I made a mistake. If I'm being honest. What did I just do? Two is the best prime? I think one is the best prime. If you know it's correct. Oh, if I ever take a class from you, I'll have to remember that. Like for actual credit, I mean. What do you mean? Did I do something that's... Right? Oh, it's not... Okay. Let me do Critical's question. I'll think about that more. Because yeah, I didn't properly answer this part. You're right. The entire complex number here can't have an angle of pi, but that we need to convert that to an angle for z. Cooper with an Wilson on learning algebra today. Said he'd been driving a cab. Prove himself he can learn math. Oh, cool. Determine if B is a linear combination of A1, A2, A3. This is just setting up an augmented matrix and doing row reduction critical. Zola, thank you for the follow. So I know that you can do row reductions critical. Like, I just want to know like how to set this up. Because like you basically take these first three vectors as your 3x3 matrix, you do a vertical bar, and then it's your B vector. Like it's a 3x4 matrix. I may need, oh wait, critical may not be here. Let me... Just showing that B can be written as a linear combination of A1, A2, A3. You hear? Okay, so critical, this is basically an augmented matrix. Like you would set up the like these first three A vectors are your first three columns, and then you have a vertical bar, and then you have your B vector, and then you just do your row reductions. Like I said, maybe like how to interpret the final answer that you weren't sure of, because I know that I've seen you do the row reduction stuff. Here, look, I'll show you how to like set it up, but I'm not going to do the actual calculations. Like, I'll plug it into Wolfram Alpha to get the end result, and show you how to interpret it, but I don't want to do all these row reductions. But like, what you do is you just set up your A vectors. Vertical bar for your augmented matrix, -5, 11, -7. And then you just get the identity matrix here, or as you try to. And you interpret that. How do I put this into Wolfram Alpha? Lubert is saying that it's not. Okay. Oh, I wish. There we go. That's what I wanted to see. But yeah, there's the whiteboard again. And then there's a like interpretation bit here. So I agree with what Lubert is getting, that the answer is no. Because once you get the row reductions, you should get this matrix here. And from that last row, you get 0 is equal to 1, which is just a false statement. So there's no solution to the system of equations there. I mean, so let me. Yeah, I mean, you can argue if they do span all of R3, you could certainly like argue that does the work for you. I think you just are potentially wasting effort if they don't span R3, and you have to go and check if it is in the span. Yeah, it's in the forum. But like I assume you're suggesting to check span by getting the determinant. That seems like a lot of potential wasted effort if it doesn't work. Like it wouldn't have worked for, well, no, it would not have worked for this one because they're not independent, right? So then you need to go back to the system anyway to check the actual span. Okay, we have a bit more thinking to do about this branch cut. So we need to exclude anywhere where the argument of this number is pi. So when you add two complex numbers, what happens to the angle? That's what I want to know. Don't get burned like yeah. My God, interpretation, adding complex numbers. Like when you multiply them, the angles add. But if you add them, I don't think it does clean, unfortunately. Oh, really? They're one talking about multiplication? Oh no, they're talking about addition up here. I just scrolled right past it. That's kind of a neat animation. Hey, how does 2 plus 2 equals 5? It doesn't. That's the answer. Dude. There should be a clean way to do this, and it's probably from pretty early on in the class. Imagine z is the negative real axis. The imaginary real axis, the negative real axis. Okay, yeah. Oh, wait. If we add them and get something on the negative real axis, it means the imaginary parts cancel. So we want to the imaginary part of z can't equal 1. No. No. Not just that, at least. in the real part of Z is less than 4, then I think it's analytic if those two conditions are met at the same time, right? Where's a cleaner way to say that? And I guess maybe just the argument of that thing not being equal to pi is clean enough. Oh wait, okay, z equals 4 plus I minus w is the geometric transformation of the negative real axis w. Well, the minus makes you go to the diagonal quadrant. So if you're in quadrant 4, you go to quadrant 1. If you're in quadrant 3, you go to quadrant 2. And the 4 plus I is a constant offset. So critical. Okay. So, sounds good, Brian. Welcome back. Hope everything's okay with you. Critical, a linear combination. The question is asking if there is a linear combination of A1, A2, and A3 that equals B. So we can take that wording and pick it apart. Or they said something like this, at least. So a linear combination means that you add the things they're listing up with a constant in front. So A1 times some constant that we'll call x1 plus A2 times a different constant we'll call x3 plus a3, I don't know how to count, x2 and then x3, and I could make this arrow a lot better, couldn't I? That's what a linear combination means. That's all it means. It doesn't necessarily even imply an equation, just a linear combination is all the things they listed added together with constants stuck in front. It comes up in other contexts too, not just with vectors like this, but the equals, of course, is an equal sign. And then b is just the vector b that we're given. And are you with me so far in how this equation is set up, ignoring like how we did the rest of the problem? Like I hope I haven't lost you already here, because the next step is how we're going to get to the matrix that I wrote on the board there. Okay. So you're with me so far? I hope that means. So this is really 3 equations with 3 unknowns, where each row of these vectors is an equation, and the 3 unknowns are x1, x2, and x3. We can equivalently write this as a single matrix of these vectors times a vector of our constants is equal to our good old b vector. Like, these two mean the exact same thing here. And we have a different type of notation that can represent this situation, which is the augmented matrix. So that's that's why we end up with an augmented matrix like that. It's kind of realizing this step in between here, I would say, I guess. Wrote down everything? Okay. Yeah, and then you do the row reductions. Where do you get stuck? So you did do the row reductions, but you maybe didn't know how to interpret it? Did you get this? So this last line is the important bit. Like, the goal of this problem is to say yes, there is a combination of x1, x2, and x3 that give you the b vector, or no, there isn't. And this last row gives us a false statement that 0 equals 1. So that means there is no x vector such that it's a linear combination. Yeah. Okay, cool. If you get a solution, then you're good. Yeah, if you get a row of zeros, I think that means you have infinitely many solutions. Like it's an... I think it would. But as long as you have one or more, that's the main thing that you care about. Okay, great. No worries. When is your final? So back to this analytic part. I don't know if this is a good enough answer, if this is a good enough answer, or if there's some third answer that's even cleaner. But I think this is getting at the fundamental idea that Cook was bringing up. Oh, hey, math channel. Sounds like it might be might have a similar interest here. So I have a bachelor's in applied math. And for me, my experience like learning math at least was I got my ass kicked in the first calculus class that I took, and I had to study every day for weeks to understand it. But then I kind of something just eventually clicked, and I feel like I finally got that fundamental understanding of what a derivative is, and a lot of the rest of math just kind of flowed from there, I guess. I think the moral of the story is just grind and grind, and hopefully it'll click eventually. But I think everyone's experience is gonna be a little bit different. I just want to quickly see what these like lectures are like. It might not be worth it for me to go through them at some point too. Word of the day, grind. Yeah. Oh, okay. So like 45 to 50 minutes each. Oh, there's a lot of them. Wow. This is worth me going through it at some point, probably. Can I like save? I don't know where I'm gonna find it later, but hopefully I can find it later. Oh yeah, like I've only learned from like other people in the math Twitch community like that the determinant has a geometric interpretation. That was just kind of like a number. And I think it still just kind of is a number, and it means different things in different contexts, but I didn't know there was that geometric interpretation too. Okay, so I feel like I'm ready to move on to number 2 here. I don't know if I've expressed B in the best, like, cleanest way, but I think I've gotten the idea well enough to move on to part 2. Find a function to represent the imaginary part. Ooh, okay. Okay. I erased the Cauchy-Riemann equations, didn't I? Okay, where the hell are they? No. No. Oh wait, yes. Do we want Cartesian or polar? Cartesian. U sub x equal v sub y. U sub y equals minus v sub x. So you're working with today had a problem where you needed to find a basis for the column space of inside of vectors. Oh, I think we were doing that. That was one of Critical's questions, I think. Because it was that question that gave you the original matrix and the row reduced version. And you had that idea that it's probably you take those corresponding columns from the row reduced. Oh, that's funny. Okay. Two x 1 minus y plus ivxy. Okay, so we are given the Cauchy-Riemann equations are satisfied. This is our u. That's not a u. This is a u. U sub x is 2 times 1 minus y is equal to v sub y by the Cauchy-Riemann equations. U sub y is equal to 2, negative 2x, tricky, is equal to minus v sub x. This is like concept of multivariable calculus too, right? We can integrate both sides of this with respect to y. This become 2y minus y squared plus some constant as a function of x, not a constant. And we take the partial of this equation with respect to x, I believe. Two x. Okay, and then we know. I think I don't know if I did something slightly wrong, but this is getting an answer. And the c's are kind of messy notationally, but I think what this is telling me is that our function v is 2y minus y squared plus 2x plus c. And we can't distinguish what that c is, right? Actually useful in the real world? Yeah, true, Fembucks. Aren't the Cauchy-Riemann equations important to proving Cauchy's theorem? Maybe Math Channel, to be honest, I don't know. This is me kind of half learning complex variables. So over on Twitch, there's a streamer named Penn Center who is doing like a real complex variables class where you can actually get like college credits for it. And you can also just take it for fun too. And I've kind of been like loosely following along with it. And this is like the midterm that he put out. So by all that explanation, I mean, I don't actually know for myself because I'm still learning. Is the short answer. We have different powers of x there, Cook. It should, because I don't know how to integrate. The integral of 2x is clearly 2x. I don't know what you're on about. The integral is just a fancy s, and it equals 1. A lot of engineering students. Oh yeah, I've heard that. I remember like tutoring an engineering student, and like on the fly, I had to learn how to solve a differential equation with complex variables. It's pretty neat, but it's not something that I ever had to do as a math major. Why would I remember that though, Cook? Oh wait, I get it. If you square any complex number, okay. But wait, how does that match the original? If there's a partial derivative, is there a partial integral? I mean, basically every integral is a partial integral as far as I know. I don't think you have that funky, like, chain rule type thing that you do. Like, if you want the total derivative for, like, x for a multivariable function, you have to go through a bunch of different branches. I don't think you need to do the same type of exercise with integrals. But, so, the minus 2xy real part. Two z plus iz squared. The real part is given by 2x minus 2xy. 2x is the real part of 2z. What? Oh. I'm still not following what you're saying, if I'm being honest. I did do the task though for part A. Since the Cauchy-Riemann equations hold, we know that we can think of this function as a legit function of z. Oh, you might have just done part B here. That might help me understand what you're saying. How do we convert this to a function of z? You did B to find A. I may need to look back at the notes to see how they did it in the class. Oh, we have these formulas. Okay. That makes it simpler. Okay, yeah. I forgot about those things. Need to write down the formulas though. Should remove all the z bars. Better a z bar than a zebra? I don't know. I think there's a pun in there somewhere with zebra, but I can't quite find it. Whiteboard, you're kind of scaring me here. Since the CR equations hold, okay. Let's write out the complete function with v plugged in. And I'd rather have it expanded out, I think. It probably doesn't matter. Ooh, maybe it's better to factor it, like Dr. Cook had it. Let's factor it and see if that makes it easier. The difference of two, no. I think I'd rather have it like expanded. Plus C. I guess so. Okay, I guess I won't cancel anything yet, but the 2 does cancel. Oh no, I don't have room. Let's think about messages, finding about patterns, finding about symmetries. I mean, symmetries, patterns, it's all the same. But yeah, there is the 2xy. There's all the other like junk around there too that I don't know what to do with. Should I get rid of the I there? Minus a negative, but you get another negative. What's that come out to be? C conjugate squared over 4. Okay. We're making our way through this algebra. C conjugate of 2 minus. Like that is what you get when you FOIL all that bit. We get the 2z z conjugate canceled with that 2z z conjugate. That's good news. Okay, let's do a whole bunch of mental math in this set, because I'm sure that I would never mess up mental math in my life. So I times that to become plus z minus c conjugate. I'm sure I'm not going to forget to multiply the I into the rest of these terms. Don't even worry about it. I would never do that. C squared over 4 plus c squared over 4 is c squared over 2. It gets an I in front of it. Or behind it, apparently. Those two cancel. These two become similar. Plus ICUP. I'm doing it the hard way, Cook, all right? I'm already this far in the algebra. I'm not stopping now. Cancel, cancel. Cancel, cancel. Cancel, cancel. Add, add. Two z, add, add. IZ squared. Counted for those 4 things plus IC. This is far easier than whatever you know crap you were saying, Cook. Come on, this is baby algebra. Far easier. Mm-hmm. So, but like, so the thing that you saw there was a 2xy, and so, oh, Obi. Thank you very much for the raid. How's your stream? I can see I'm trying to use problems in clever ways because I know the subject and I don't want to grab pencil and paper. That's fair. Like, so you just saw the 2xy and you were trying to reverse engineer whatever z had to be to get you like that 2xy term, curriculum for tomorrow's class. Nice, nice. We just did the last problem on Penn Center's midterm for the complex variables. You know 2x was part of the real part of 2z. Then try to fix DaVinci Resolve so you can actually post to YouTube. Oh, dang. I actually used the DaVinci Resolve for my editing too. I don't know that I'll know whatever issue you're having, but it served me pretty decently the more that I've learned about it. I knew z squared has imaginary part 2xy. So I z squared would have real part 2xy. Okay. Oh, I forgot. Yeah, if you're on Ubuntu, that's probably gonna make everything harder. Okay, I want to put a little bit more out. If you let z equals x plus iy, that means z squared equals x squared minus y squared plus 2ixy. And so what you did is took this and multiplied everything through by I. And then we just need to figure out the 1 minus y, well, sorry, the 2x and the 2y. Actually, it's really bugging me I didn't factor the I out over here. There we go, much better. And so we have a 2x, oh, a 2x and a 2y, I see now. So you can add that to each side as well. Okay. Clearly this is the better way, you know? Might be able to do it on Winbox, I guess. That's annoying, just have to do like a VM for everything. We've been talking about harmonic function solution to the Laplace equation. That sounds familiar, Fembox, yeah. Those vector calc theorems feel like they'd be applicable when we're talking about Green's theorem. Should be simply connected to work. We just think no poles inside. Oh, that's true too, Cook. I guess C is a complex. No? I disagree with that. C came from a real number problem, from that integration, did it not? I mean, you probably could absorb it in there without a significant consequence and call it an imaginary constant, but I think it came from a real context, didn't it? But we were only integrating U and V. Well, yeah, but the imaginary part is real. It's real times I. You can always add a constant. I probably shouldn't be debating complex numbers of people know about it, who know way more about it than I do, but apparently I feel compelled to. We are told the given real part is no constant. Without disturbing the analyticity. I need that word on a soundboard so I don't have to say it. I can just play the soundboard. Yeah, I mean, I think it's a technicality that really doesn't matter for the overall thing. Like, it's still a constant that would derive to 0. Well, does I derive to, it should, yeah, okay. Differentiate to 0. I don't know. Okay, there's some neat problems this like midterm. That was the last one that Penn Center put on there. We didn't have to do it, like the students only have to do 2 in total. But you know, I'm the nerd who would always do extra credit for my classes despite already having good grades, so 10 bucks so pedantic. I mean, you are right. I only care about it when I feel like caring about it, I guess. Derive, it's derive, differentiate. You know, derive is less than half the syllables. Net 3 will say. By saying derive instead, I'm saving years of my life that I, you know, don't have to spend saying I don't spend saying rentiate. You stand with Fembox here? You do physics, Dr. Cook. Derive is approximately differentiate. You know, physicists love approximations. I'd like to keep the stream going for a little bit longer until Penn Center starts up. So maybe we'll do a little bit of per selling. Where am I in chapter 4? Arrives the first order Taylor approximation to differentiate. Exactly. I think I just got through like section 9, and this thing looks like a dick. I'm sorry. This Van de Graaff generator. Like, why does it have to be shaped like that? But I'm way ahead of you. Yeah, I mean it's no pressure. Like, we could always just like cancel the Saturday one anyway, or if we do it, we can do it on chapter 3 still. Yeah, I think I would just get started on section 10, but I honestly, like, I need to... I'm kind of just trying to get all the text through my brain and then go back through it a second time. I kind of feel like that's what I need. Electric motive force in the voltaic cell. It's a good question. The electromotive force... So, okay, the voltaic cell is the fancy word for a battery. The generic name for a chemical source of electromotive force. The electromotive force is basically it's like the effect of the battery pushing electrons through the circuit, is my understanding of it. Like, rather than the electrons just like hanging out here, they need to be pushed through by a field, I think. And I think that's the idea of the electromotive force. For that EMF is an outdated term, but not sure. I mean, there's even in this book. I don't know when this 3rd edition was like put out though. I might just go back to chapter 3 and do a chapter 3 problem. So I think if I read this on stream, I'm not going to get anything out of it. I mean, I'm already not getting that much out of it anyway. Am I a nerd over circuits? Not particularly. So, yeah, see figure 4.19? You're welcome. So, a couple months ago now, I guess, I wanted to start a reading group of some kind, because I just like interacting with the community and getting like other people like involved here. And I wanted some way to like apply multivariable calculus in a fun context. And so I asked a physics streamer like where in physics that might happen, and he said electricity magnetism. This book was one of his recommendations. So on Saturdays, we do an actual like reading group on this book, and sometimes during like slow times of the stream, I'll pick up some problems. So I'm not particularly like, I'm more interested in the math behind the physics, but the physics itself has been pretty fun too. I don't have Crane. I'm pretty good at finding PDFs in a way that's definitely legal and ethical, unquestionably. I would never do anything that is, suspect in that sense, but I haven't gone about legally and ethically locating a PDF at this point. Dark copy, but it's work. Did we do... Was this an image short problem that we were doing? No, we didn't do a spherical shell. So put 16. Oh, 3.13 might be like a 4-star problem, which probably I would have avoided it. They might just... Okay, it's a 3-star, that's why I avoided it. But they might give us where the... Yeah, I mean, I think they're just talking about the same system from 13. We don't necessarily have to solve it. I mean, I'm not above even attempting a 4-star problem at some point, but... I mean, okay, let's just look at 13. We can't be scared of 3 and 4-star problems forever, right? Point charge minus Q is located at x equals A. Point charge Q is located at x equals A. Show locus of points with phi equals 0 is in a circle in the xy plane, hence a spherical shell in space. Isn't it not, though? You get something that's almost like a goggle shape, I thought. Where it's like a circle around each point. If you're far enough away, they'll become circular. Sure. Because they just start to look like a point charge. So me up, you didn't draw the minus Q charge. Yeah, I'm trying not to look at figure 3.25. I see it's not mentioned until part D, and it's kind of confusing me here. Oh, there is 3.26. That's not mentioned until part E, though. I'm still confused on part A. Like, it's what's the point with phi equals 0 specifically? Maybe phi equals 0 is specifically a circle. How do we figure phi equals 0? It's when the work from the negative charge has canceled the work from the positive charge. Right? If the magnitudes were the same, would it be a plane? Yeah, like or I guess, I don't know. If the magnitudes were the same, no, because one is farther, is it? Oh, true, yeah. Let's murder this problem. I mean, I'm already getting held up on part A, but we can do some attempted murder on this problem. Why do I draw it so small? Trying to draw things asymmetric, just to not accidentally make an assumption here. Well, E or phi? Do you want to calculate E and get the derivative? No, it's the other way around. E is del phi. You're right? Okay. So the total phi is k, I guess we'll start with a negative charge. That. The positive charge. That. Let me take it equal to 0. The k's cancel. How do you get a circle out of this, man? X plus A? Well, neither of them have to be negative. Okay. You can make all the mistakes you want as long as it involves like telling me that I'm right. I do enjoy that. If we add this to the other side, it goes over there. So we want to, this one goes on top. Is this what we want to do? Like, the radius is going to be q over q squared, and then this somehow hopefully simplifies in a way that I have no idea how. Starting from the top equation? Okay. For one term other, square both sides, invert both sides. Oh, that's a lot. Yeah. Okay. You're right. Good call. the charge is going to be mixed in, which is kind of annoying. I guess we can deal with it though. It's an A, not a Q, I promise. Their location between the 2-point charges where phi equals 0. Yeah, I'm not really... I don't know what the circle is going to be like. These have opposite signs. So actually, maybe I'll just do that. Oh my god, okay. Oh. Messed up a sign there. So they all have a 1 over q squared minus 1 over q squared term. Factor, I should say. No. No, never mind. If those A's were the same, then we'd be okay, but... Our picture is inherently wrong. Really? Yeah, I didn't want to complete the square. I mean, they don't put any stipulations on A and A, so I intentionally made them opposite signs. But they could both be negative or both be positive. So the thing you do to complete the square, you do plus and minus b over 2a squared. Well, first, okay, please save me from my torture. I'd rather do my annoying complex variable algebra. Well, that's not going to cleanly divide out with the not x squared and y squared terms, right? You have to, well, oh yeah, I mean, we're good, definitely, I guess you're right. We were going to do that eventually anyway. Just do a little side work though. To make the division part a little more clear what's happening. Oh, I thought we'd have a trick and we don't. That's annoying. All right, we just got to do the good old-fashioned. Oh wait, we do have a trick because you have to flip it. There we go. That's the trick that I wanted. Because we can do just that q squared over q squared first. Like that. I guess I could have brought the denominator in too. Okay. Like that. So the point on the x-axis between the 2 points still p equals 0. The second point? Okay. So this is the exact same math. But the sign is flipped and there's no 2. Like that, and that's our constant. That's the radius squared. Wait, no. We're trying to complete the square. Wait, what am I doing here? What did I? Oh, I haven't completed the square yet. Okay. Now we complete the square. Jesus. Okay. Yeah. It felt like so much work that I thought we had completed the square. We haven't gotten that far yet. So b over 2a. So really, we just get rid of the 2's there. Really? Well, the square. Okay. So plus this thing divided by 2 squared. No 2. Now the original problem repeated. Okay. And this thing, it factors to x plus the square root of that thing squared without checking it. I did not make an assumption like that, no. Now, do not ask me to prove this. I'm going to make the claim that this factors to that. This stuff, we move on the right side because that's our radius squared. Is there... Does that simplify in a pleasing way? It nearly does. I don't think it actually will, though. Will it? No, I don't think so. We could simplify that a little bit. Get into one fraction. Ugh. What is this thing saying? I thought it would be a bit of a cleaner answer than just a whole mess of constants. I think we have answered part A, though, technically. You want to tighten this up? All right, maybe it'll be something that's like astoundingly clean. You know, let's be optimistic. It's not just be a second mess of constants, I'm sure. Let's do side work. You know, I was the one who was saying, let's do a whole bunch of pointless algebra before, and now we switched roles. Not squared. Well, I'm multiplying the one on the right by q squared minus q squared squared. not squared. There we go. Oh shoot, Penn Center's going to be live soon, if not already. Let's see if we can at least get through this algebra, though. Alright, multiply out the top. Wait, can we factor? This thing does factor. Because these two are actually the same thing. No, you're not squared. Well, that one we can make it so it matches, though. You factor -1 out, and then -1 squared is 1. Okay. Maybe this isn't as terrible as I thought it'd be. Well, it's still pretty terrible, though. What happens here? I think that's my claim. Don't know how much work that actually saved, but a little bit. I guess let's group it by cube squares. I think that's good. Okay. Now we expand the parentheses. A squared minus AQ to the 4th. That turn into that term, this term into this term. A minus A. A. A minus A. Q squared, Q squared. These are not, they're not even adding. Okay, that's cool. I don't want them to add. This times this. Yeah, Q to the 4th. That. I don't think there's a cancellation here. I don't think this was helpful to do. I don't see. Oh my god. Yeah, I think I would just keep it in the form of my last black step, to be honest. Because I don't see a cancellation or any sort of cleanup there. Is Penn Center going yet? Penn is live? I'm pretty concerned that I did make an algebra mistake at some point, but I'm gonna take a screenshot of the whiteboard because I do want to. Oops, sorry for that. I do want to come back to this problem. Go do that quick. Here for 3.13, I'm seeing our answer. 3.13 for A, taking it for later in case we come back for the rest first. Okay. Yeah, I mean, this is a sphere, or a circle, and then when you bring it to 3D, it's a spherical shell. So I think we did the task for part A. I still might have made an algebra error, but anyway. I'm cutting the YouTube stream off here, so enemies here on YouTube, I appreciate you. I'm back on YouTube on Thursday.